As far as we know, it's the only home to life in the universe. Why? What is it that makes our planet so special? The answers are hidden deep in the Earth's past. To find them, we must travel back in time to see the first humans walk the Earth, to ride continents on a collision course, face killer dinosaurs, dive into oceans full of bizarre life forms, feel the bitter chill of global ice ages, and experience the fury of cosmic missile attacks. We must travel back in time until we reach the birth of the Earth itself. Then we can piece together our planet's incredible story and discover why all of this, all of us, are here. Our journey starts almost 5 billion years ago. But this can't be right. There's no sign of our beautiful blue planet. Just a newborn star, our sun, surrounded by all this dust. We've arrived too early, before the Earth has even formed. Speed up time, and we can see gravity pull the dust into tiny rocks. It hardly seems possible that something as complex as a planet is made from nothing more than dust and rocks. Over millions of years, gravity pulls these rocks together to form the Earth. One of at least 100 planets circling the sun. But 4.54 billion years ago, our planet looks more like hell than home. Up close, the temperature is over 1200 degrees Celsius. There's no air, just carbon dioxide, nitrogen, and water vapor. It's so hot, so toxic, that if we got any closer, we'd be incinerated and suffocated in seconds. The newborn planet is a boiling ball of liquid rock. There are virtually no solid surfaces, just an endless ocean of lava. A young planet called Theia is heading straight for us. It's the size of Mars, and it's traveling at nearly 15 kilometers a second, 20 times faster than a bullet. The intruder's gravity is distorting the Earth's surface. blast wave races out around the planet. It's as though both young planets turn to liquid. Trillions of tons of debris blast out into space. But over the course of just 1,000 years, gravity works its magic and turns the rubble into a ring of red-hot dust and rock that circles the Earth. And now, from this ring a ball forms, over 3,000 kilometers wide. We're watching the birth of our moon. It's much closer than the moon we recognize, just 22,000 kilometers away, instead of about 400,000 kilometers. The sun rises over a cooling Earth. And sets just 3 hours after it rises. The impact has set the Earth spinning so fast that an entire day lasts just 6 hours. The days may pass quickly, but the Earth changes slowly. To understand the making of our planet, we need to fast forward through millions of years. A hail of meteors. $3.9 billion years ago, and we're under attack from debris left over from the solar system's formation. Look at these strange crystals inside the meteors. They look like grains of salt. The same salt you'd put on your French fries. And inside these, minute droplets of water. It seems these deadly missiles could contain the vital ingredient for life on Earth. There's only a small amount of water inside each meteorite. But as they bombard the Earth for over 20 million years, pools of water grow. The water collects on solid ground. The Earth's core remains molten, but its surface has cooled to around 70 or 80 degrees, just enough to form a crust. In the future, we could swallow this water when we take a drink. Every sip, every puddle, every drop of water in every ocean is billions of years old. And it may have traveled millions of kilometers to reach us, carried inside a meteor. The Earth looks more familiar, but this is still a dangerous place. This wind is as fast, perhaps faster than the most destructive hurricane. It's a megastorm, whipped up by the planet's rapid rotation. The Moon is so close to Earth that its gravity is overwhelming. It creates huge tides that race across the planet's surface. But over time, the Moon moves away. The waves calm, and the planet spins slower. "700 million years after the planet's birth, life-giving water covers its surface. But not just water. There's something else down there. Tiny islands. They seem to have appeared from nowhere. Until molten rock bursts through the Earth's crust and rises up through the ocean. Over time, the lava cools and forms a volcanic island. This is how these islands formed. In the future, they will join together to form the first continents. The infant Earth has water and land. It's beginning to look like the planet we call home. But the atmosphere is toxic, and the temperature is scorching. Nothing could live here. Meteors. They've been raining down since the planet's formation. But now, 3.8 billion years ago, the assault has entered a violent new phase. Something has disturbed the orbits of these meteorites. They already brought water to the planet, but they're carrying something else too. As the meteorites dissolve, they release their minerals and transport carbon and primitive proteins, amino acids, from outer space to the bottom of the ocean. It's dark. The sun's rays can't reach beyond 300 meters, and it's close to freezing. This must be a mirage. A city of underwater chimneys. It's not smoke. It's some kind of hot liquid. Seawater has seeped down into the Earth through cracks in the crust, getting hotter, collecting minerals and gases on the way. It's this potent mixture that's spewing back out into the ocean, building these towers. Add to this all those minerals and chemicals from the meteorites, and the water has become a chemical soup. It's impossible to know how or when, but somehow these chemicals have come together to create life. The water is now full of microscopic organisms. These single-celled bacteria are the earliest forms of life on Earth. This is a defining moment in the making of the planet. Microscopic life is underway. To find more complex life, we need to travel forwards through time to 3.5 billion years ago and a shallow ocean. These look like rocks, or even plants. They seem to grow out of the seabed. Each is a mountain of living bacteria, a colony called a stromatolite. As if by magic, these bacteria turn sunlight into food. This process, called photosynthesis, uses the power of sunlight to transform carbon dioxide and water into glucose, a simple form of sugar, and similar to the stuff we put in our coffee. And this magical transformation releases a byproduct, a gas called oxygen. Underwater, the stromatolites slowly fill the oceans with oxygen. The oxygen turns traces of iron in the water into rust. This falls to the ocean floor to form deposits of iron-rich rock. One day we'll use this mineral to build bridges, ships, and skyscrapers. Above the waves, the oxygen transforms the atmosphere. These stromatolites are creating the single most important element for life on Earth. Without them, virtually every living thing wouldn't exist. When we take our next breath, we're doing it thanks to these colonies of ancient bacteria. Over the next 2 billion years, oxygen levels continue to rise. And as the planet's spin slows, the days get longer. Now they last at least 16 hours. We're discovering it takes a long time to make a planet. 1.5 billion years ago, 3 billion years after the planet's birth, and there's no complex life. No plants, no dinosaurs, no humans. But the Earth has something that no other planet has. A force with the power to change everything. Our planet, a beautiful blue ball, dotted with volcanic islands. 1.5 billion years ago, it's home to primitive life. Over millions of years, we can see something is rearranging the islands. Hidden beneath the ocean, the Earth's crust has broken into vast plates. Deeper still, the Earth's core is at work. It's hotter than the surface of the sun. So hot, it generates movement in the rock beneath the crust. These movements push and pull the plates around the globe and carry the oceans and the islands with them. Millions of years race by. Seeing it like this, our planet seems active, changing, alive. Over 400 million years, a vast new supercontinent takes shape, called Rodinia. In the shallow waters around Rodinia, stromatolites have been working their magic for over 2 billion years, pumping oxygen into the atmosphere. The temperature is 30 degrees Celsius, and the days are 18 hours long. But this looks more like Mars than Earth. To find life here, we need to move on, through time. The state of Washington, 750 million years ago. Some force from deep inside the planet itself is ripping the crust to pieces. It's as though the world is tearing apart. And there's only one force powerful enough to do this: heat. It escapes from the Earth's molten core, stretching and weakening the crust. Centimeter by centimeter, year by year, the great supercontinent is splitting in two. The intense geological activity has spawned a mass of volcanoes. These pump carbon dioxide into the atmosphere. There's smoke and gas everywhere. All that carbon dioxide mixes with water to make acid rain. The rocks absorb the acid rain, including its carbon dioxide. And there are a lot of rocks on the Earth right now, exposed when the continent tore apart. So many that vast quantities of carbon dioxide are absorbed out of the atmosphere and locked up in the Earth's rocks. There's not enough carbon dioxide in the atmosphere to trap the sun's heat around the planet. In just a few thousand years, the temperature plummets to around minus 50 degrees. This frozen wasteland is southern Australia, 650 million years ago. It's the start of what some scientists call Snowball Earth, a period they believe to be the longest, coldest ice age ever to grip the planet. a vast wall of ice, thousands of meters high. The ice is unstoppable. The more ice there is, the more sunlight it reflects away from the planet, and the faster the ice spreads. And there's a second ice sheet, just as high. The two sheets spread away from the poles towards each other to meet at the equator. Now, an ice sheet up to 3 kilometers thick entombs the entire planet. First, the planet was a molten ball of fire. Now, it's a frozen ball of ice. Virtually all the sun's light and warmth reflects back into space. But it can't last forever. Something must release the Earth from this frozen prison. And when it does, who knows whether life will have survived beneath the ice? The surface is frozen, but the core is still hotter than the sun's surface. Volcanoes have been erupting since the world began to freeze. But up until now, even their heat and power made no impact on the ice. Volcanoes pump out billions of tons of carbon dioxide. Before the big freeze, the Earth's rocks absorbed most of the CO2. But now, with the rocks smothered in ice, there's nothing to absorb the gas. So it fills the atmosphere. Like a blanket, it traps the sun's warmth around the planet. Temperatures rise until now, after 15 million years, the ice begins to melt. It's thought that during Snowball Earth, the ice pushed the crust down. Now, as it melts, the crust bounces up. This creates fissures and weak spots, and more volcanoes. These volcanoes release more carbon dioxide and push the temperature up even higher. The melt gathers momentum. Oxygen levels rocket. Through a series of chemical reactions, the ice has created oxygen. While the planet was frozen, the sun's ultraviolet rays reacted with water molecules in the ice to produce a chemical rich in oxygen. Hydrogen peroxide, the same chemical that bleaches hair. Now, as the ice melts, the hydrogen peroxide breaks down and releases massive amounts of oxygen. The Earth is waking up, and it's a very different place. Now, 600 million years ago, the atmosphere is warmer. It feels like a summer's day. And the days are about 22 hours long. Add all this water, and it's the perfect recipe for life. Before Snowball Earth, primitive bacteria had emerged in the oceans. But surely they couldn't have survived an ice age 75 times longer than the entire span of human history. If something has survived, then our best chance of finding it is where we last saw life, in the ocean. Now, 540 million years ago, in an ocean full of oxygen, those primitive bacteria have evolved. A handful must have clung on through the big freeze. There are plants everywhere. And something else. It looks like some kind of armored slug. It's called Wiwaxia. It's one of a new generation of complex multi-celled organisms. We're entering one of the most dynamic periods in the Earth's story, the Cambrian Explosion. Increased oxygen levels allow creatures to grow larger and develop bony skeletons. There are worms, sponges, and these. They're trilobites, distant relatives of insects, lobsters, even scorpions. Life in the oceans is blossoming. From microscopic bacteria to a monster like this. This is Anomalocaris. It's about 60 centimeters long. Look at its large eyes, its razor-sharp teeth and grasping limbs. All Anomalocaris has to do is take its pick. The trilobite can't right itself. Its soft belly is exposed. These are Pikaia. They're just 5 or so centimeters long, but they've got what may be the first ever spine. Over millions of years, this simple structure will evolve into the spine that keeps us standing erect. And creatures are beginning to take on familiar forms. Beneath the waves, there are already tens of thousands of plant and animal species. The advance of life seems unstoppable. We're looking for life on land. 460 million years ago, and the plates have moved again. Below lies a new continent, Gondwana. It's a warm 30 degrees Celsius. Oxygen levels are close to those in which we live. The land should be covered with plants, crawling with creatures. But there's not much here, beside a few patches of algae. There's only one explanation. The sun. It blasts the surface with deadly radiation. The complex life we've seen in the ocean doesn't stand a chance on land. But 50 kilometers up, where the rays enter the Earth's atmosphere, something strange is happening. When oxygen meets the sun's radiation, the oxygen turns into another kind of gas, called ozone. This gas forms a blanket around the planet. This ozone layer absorbs the lethal radiation. Over 120 million years, the ozone layer gets thicker and stops more and more radiation from reaching the Earth's surface. Without this layer, life on land simply wouldn't exist. Now, shielded from radiation, life blossoms. Those small mossy lumps are the first land plants. And they're pumping out even more oxygen. Levels soar. $375 million years ago. There's something down there, in the water. It's moving, swimming. It's a strange fish called a tiktaalik. Its neck allows it to raise itself up. It uses its fins as if they're legs. And moves out of the water, where plant life is exploding. Over 15 million years, these creatures called tetrapods evolve. They grow stronger limbs and spend more time out of the water, until 360 million years ago, they make the land their home. It's from a creature like this that all four-legged vertebrates will evolve. Dinosaurs, birds, mammals, and eventually you and me. We've come a long way, from a lump of burning rock and dust to a blue-green planet bursting with life. There are still no humans, But there are fish, plants, and this. It's a dragonfly. A dragonfly the size of an eagle. This giant is called Meganeura. What were once legs have evolved into wings, extending the dragonfly's hunting territory over a vast area. There are millipedes, spiders, all sorts of bugs down there. These creatures, called arthropods, were among the very first to set foot on land. They've already been around for hundreds of millions of years. They look almost identical to the bugs that invade our homes today. Except for one big difference. Like Meganeura, they're monsters. We've stumbled into a lost world of giants, where millipedes are 2 meters long, and scorpions the size of wolves. All the oxygen in the atmosphere allows their respiratory systems to be more efficient and frees up space for their bodies to grow. A lizard-like creature called Hylonomus. The creatures we've seen so far laid their eggs in the water. But these eggs contain all the water and nutrients the developing Hylonomus needs. The babies are growing in their own self-contained pond. The egg is a major evolutionary breakthrough. Now animals can leave the water behind and conquer the land. This baby Hylonomus will lead the advance. It's a new kind of creature, a reptile. Inevitably, with life comes death. There's so much dead plant matter, it builds up and decays into dense, soggy layers. Over hundreds of millions of years, rocks will cover these layers. Heat from the Earth's core and pressure from the overlying rocks will transform the layers of dead plants into seams of coal. Each lump of coal we burn today to warm our homes and fire our power stations is made of plants that died 300 million years ago. Amidst the decay, hidden from sight, life is stirring. Soon seeds will germinate, plants will grow, and this wasteland will live again. Life seems to have conquered the planet. A herd of creatures graze the Siberian plains. They're not dinosaurs. They won't set foot on Earth for at least another 20 million years. But they're big. Evolution has taken a huge leap forwards. The small lizards we saw earlier are now giant reptiles. These are scutosaurs, the distant relatives of turtles. They're plant eaters. And if the plant eaters look this tough, the carnivores must be seriously mean. It's a Gorgonopsid, a perfectly engineered prehistoric killing machine. The Gorgonopsid's saber teeth have wounded the scutosaur. The predator is watching as its prey grows weak from blood loss. Until... hold on. It's backing off. Something strange is happening. The ground is getting hot. There must be enormous pressure beneath the surface. There's lava, but this isn't one single volcano. The entire landscape is erupting. It's a flood basalt eruption. A massive plume of mantle is rising up from deep inside the Earth, pushing molten rock out through fissures in the Earth's crust. The lush paradise is now a lifeless hell. The scutosaurs and the Gorgonopsids are dead. They're the first casualties in the greatest mass extinction the world has ever seen. The Permian Extinction. On the other side of the continent of Gondwana, it's as if nothing happened. Snow. But the temperature is about 20 degrees Celsius. It's not snow, it's ash. Fallout from the eruption some 16,000 kilometers away. The ash burns, suffocates, and kills animals around the world. The atmosphere is full of sulfur dioxide from the eruptions. As it rains, the gas turns to sulfuric acid and burns everything it falls on. At first, it seemed like this was a local disaster, but now it's gone global. The Siberian eruptions increase the Earth's carbon dioxide levels. The atmosphere gets hotter. Water evaporates. Vegetation dies. We thought life had finally found a foothold. Now it looks like we were wrong. There are no signs of life on land, but in the oceans, this can't be right. The oceans are turning pink. And the plants, the trilobites, the predators, everything's gone. Everything except for this pink algae. The new hotter atmosphere must have heated the oceans and stripped them of oxygen. Now, nothing except algae can survive in the stagnant water. The Siberian eruptions are transforming the entire planet. Nothing, not even the deepest ocean floor, is beyond their reach. Look, bubbles. But it's not oxygen, it's methane, escaping from vast pockets of methane gas beneath the seabed. Methane is a greenhouse gas, at least 20 times deadlier than carbon dioxide. Until now, the gas has been frozen, but as the sea temperature rises, the gas begins to melt. Released into the atmosphere, this powerful gas pushes up temperatures even further, up to almost 40 degrees, 6 degrees hotter than before the Siberian eruptions. Now, even the creatures that have made it this far are doomed. It's 500,000 years since the eruptions first began. And all this time, for 500,000 years, the lava has been pouring out. By now it covers an area the size of the United States, with a layer of molten rock nearly 6 kilometers deep. 250 million years ago, we're back where we started, on a lifeless planet. Almost. It's 50 million years since virtually all life on Earth was wiped out, and the planet has been transformed. It's now 200 million years ago, and there's just one supercontinent called Pangaea, stretching from pole to pole. After the trauma of the mass extinction, the planet is healing. Temperatures are stabilizing. The acid rain is neutralizing and vegetation returning. And with 95% of all life on Earth wiped out, the field is open for a new species to emerge. One that will dominate the planet like no other before or since. The dinosaurs. These dinosaurs are called amosaurs. Like all dinosaurs, they've evolved from the handful of reptiles that survived the Permian Extinction. At 4.5 meters tall, their size makes them slow and vulnerable. A Dilophosaurus. 2 of them. They're small and fast. Tyrannosaurus is too big a meal for one Dilophosaurus, but not for two. The dinosaurs have repopulated the Earth, but no species can tame this restless, volatile planet. The Earth's crust is thinning here. It's releasing lava, shaking with earthquakes, as though it's being stretched by some unseen force. And the same thing is happening all the way down what will be North America's eastern seaboard. The Earth's plates are on the move again. 190 million years ago, the great supercontinent of Pangaea breaks up. A vast slab of land has broken away. It creates a chasm, and this fills with a new ocean called the Tethys, over what will one day be the Middle East. Currents are pushing nutrients up into the coastal waters running along what will be Saudi Arabia, Iraq, and Iran. And the nutrients attract fish in their millions. And with so much life, also comes death. Dead fish and plankton carpet the ocean floor. Over the next 10 million years, layers of rock will bury and heat the dead creatures. Ancient fish and plankton will become oil. Every liter of fuel in our cars, every piece of plastic on the planet, the paint on our walls, the carpet under our feet, even the soap we wash with, almost all originated in this way. $180 million years ago, and further west the North American plate is still moving away from the European and Asian plate. It happens slowly, at about 2.5 centimeters each year, the same speed as our fingernails grow. But hit fast forward, and a new ocean forms right beneath us, and new continents. Montreal moves away from Marrakesh, New York from West Africa. The world as we know it is taking shape. The chasm between the two continents fills to create a vast ocean, the Atlantic. And there in the middle, a volcano. We've seen plates move before. We know it's caused by currents deep beneath the Earth's crust. This process is happening down there, right now. The entire sea floor has been torn in two and pushed up into a ridge of mountains and volcanoes. It's growing higher than the Himalayas and longer than the Rockies. The water's hot here. Molten lava is forcing its way out from deep inside the Earth. As the lava cools, it's creating a new range of volcanic mountains and new ocean floor. This is what's pushing the plates and Pangaea apart and rearranging our world. It's this geological activity that makes the Earth restless, creative, unique. And every time the planet reinvents itself, the things that live on it must adapt and evolve. Things like these, they're ichthyosaurs. Their reptile ancestors lived on land, but as the planet changed, so did they. They grew fins and moved into the newly formed Atlantic Ocean. This one is 6 meters long and fast. It travels at about 40 kilometers an hour. It's the ocean's fastest creature, the most efficient predator, and it's ruled the Earth's oceans for 50 million years. But now there's a new contender for the crown. A pliosaur. Longer than a bus, as heavy as a truck. Its jaws are immense, over 8 times more powerful than a great white shark's. And its teeth are 30 centimeters long. The Earth, and the creatures that live on it, has changed beyond recognition. This was once solid ground. Now it's the Atlantic Ocean. It was on this very spot that we stood and watched Amazons graze and Dilophosaurs stalk their prey. The dinosaurs' world may be different, but they're as dominant as ever. They appear invincible. It's a shrew-like mammal, and it's evolved from the small number of mammals that survived the mass extinction 185 million years ago. It's also prey for the dinosaurs. This is why most mammals live in the trees or underground and venture out at night. Mammals are no threat to the dinosaurs. Nothing on Earth can challenge their dominance. Nothing on Earth. It's a lump of space rock, a large one. This asteroid is about 10 kilometers across, bigger than Mount Everest. And it's traveling at over 70,000 kilometers an hour, straight towards the Earth. heading for the Gulf of Mexico, just off the Yucatan Peninsula. It travels so fast, blink and we'd miss the impact, unless we slow down time. It's a split second that will change the world forever. At the moment of impact, the asteroid's back edge is still at nearly 11,000 meters, the same height as a commercial aircraft flies. The asteroid strikes with such immense force, it destroys everything it hits. Even the asteroid itself instantly vaporizes. The impact unleashes the energy of millions of nuclear weapons. Nowhere is safe, not even way up here. Some of these boulders are as big as entire city blocks. The blast wave races out from the impact zone like shrapnel from an exploding bomb. After impact, thousands of kilometers from where the asteroid struck, the Earth is under attack from every direction. Boulders rain down. Earthquakes shake the ground. And tsunamis batter the coasts. But the onslaught has only just begun. The plume of molten rock and dust spreads out and engulfs the planet. The entire sky is acting like a giant sun lamp. The Earth's surface heats up to 275 degrees. Vegetation begins to spontaneously ignite. Even months after the impact, smoke and ash still block out the sun's rays. With less sunlight, plants die, and the animals that eat them starve. Against this onslaught, it's hard to see how anything can survive. The dinosaurs' 165 million year reign is over. But the dinosaurs' demise is an opportunity for another species. Mammals. By living underground, they've avoided the heat and the fires. And by eating anything and everything, they thrive while more selective eaters die. These are the unlikely inheritors of the dinosaur's crown. And as one story ends, another begins. With the dinosaurs out of the way, this could be our ancestors' chance. The dinosaurs are long dead. The planet is peaceful. In this new world, our mammal ancestors are evolving. This lake, 47 million years ago, in what will one day be Germany, should be the perfect place to spot them. This isn't like the mammals we saw earlier. Its eyes and brain are bigger. This is Darwinius massillae, or Ida. She looks nothing like us, but fossil evidence from our own time tells us these creatures could evolve into monkeys, apes, and eventually humans. We're looking back through 47 million years of evolution to what may be one of our earliest known ancestors. The lake sits on a volcanic crater. It belches out noxious gas. Now, the lake that killed her will preserve her in its oxygen-depleted depths. One day, when the water has gone and Ida is fossilized in stone, we will discover her and recognize in this primitive primate what could be the very beginning of our own story, the story of human life. We're closer to understanding how everything we've seen, from ocean bacteria, through walking fish, and subterranean rodents, leads to us, and to understanding how our planet was made. "47 million years ago, and the atmosphere is much like our own. The temperature is 24 degrees Celsius. And a day lasts just under 24 hours. The Earth we're looking at now is almost identical to the planet we call home. Almost. The Earth's plates have been on the move again, with the continents on their backs. India moves north towards Asia. the Indian and Asian plates are locked in a titanic struggle. Neither plate is winning. Both plates begin to buckle. What was once ocean floor contorts upwards along a 2,500 kilometer line. A vast mountain range rises up. 1,500 meters, 4,500 meters. Now over 8,000 meters. These are the Himalayas. And there it is, the highest mountain of all, Mount Everest. When the snow on the peaks melts, it feeds great rivers. The Ganges, Indus, Yangtze, and Yellow rivers. The Himalayas are like a vast water tower. One day their rivers will supply water for almost half the world's population. "20 million years ago, this is our planet, with every continent, every ocean, just as we know it. Except there's one thing missing. Us, the human race. For humans to evolve, something somewhere down there has to change." Along Africa's east coast, between the plates that make up the Earth's crust, a great rift opens up. The rift stretches nearly 6,000 kilometers. Along its edge, mountains grow. There. It looks like an ape, not a human. It might stay in these trees forever, but its world is changing. The growing mountains act like a wall. They stop moisture from the Indian Ocean passing over the land. It's getting hotter and drier. The lush rainforest is becoming arid savanna. The new hotter climate destroys the creatures' habitat. It forces them to search further afield for food, to stop dragging their knuckles on the floor like apes, to stand and walk on 2 feet. It's the most important step in the human story. This mountain range along Africa's east coast could be the reason we walk on 2 feet. It seems incredible. The random movement of 2 plates may have kick-started a chain of events that will lead to the first humans. man and child. It could be a scene from our own time. But it's 1.5 million years ago. These are an early species of human called Homo erectus. And these are the first footprints like our own. Civilizations past and present. Everyone that's ever lived. The greatest inventions, the most brilliant ideas. Human history, in all its complexity and splendor, begins here and now. The climate changes again. 70,000 years ago, sea levels fall. The gap between Africa and Arabia shrinks down to just 13 kilometers. The Red Sea is narrow and shallow enough for this small group to cross out of Africa. They're another, later species of human called Homo Sapiens. They've made it across. Scientists believe every man, woman and child outside of Africa is descended from these 200 or so individuals. Over time, our ancestors multiply and spread out to India, onto Asia, and into Europe. But while humans head north, a giant wall of ice travels south. Europe, 40,000 years ago. Our Homo sapiens ancestors are arriving, only to find a world that's changing fast. It's getting colder. It should be the height of summer, but the plants are frostbitten. The rivers are frozen. Natural changes in the Earth's orbit, CO2 levels, and the flow of warm water around the planet conspire to lower the Earth's temperature. The Earth and its inhabitants enter an ice age. Glaciers as high as skyscrapers creep over the northern hemisphere at 30 centimeters a day. Slow and powerful, they sculpt the landscape as they move over it, gouging out great depressions. The planet will never look the same again. Now, around 20,000 years ago, they grind to a halt. Much of the northern hemisphere is covered by ice sheets up to 2.5 kilometers thick. With trillions of gallons of water locked up as ice, sea levels fall. "20,000 years ago, a strip of land emerges from the ocean between Siberia and Alaska. It's a bridge between two vast continents, a gateway that takes humans from Asia to a new world, America. It's the last great continent to be colonized, the last great human migration. And somewhere down there are the first Americans. Now, 14,000 years ago, the changes that triggered the Ice Age go into reverse. As the ice retreats, it reveals a very different northern hemisphere. The glaciers gouged out huge depressions. Now they fill with water to become North America's Great Lakes. "6,000 years ago, the ice retreats back to the poles, to the Arctic and Antarctic. After a 4.5 billion year journey, we've made it. We're back home. This is our world, our time. Now, for the first time, we can piece together our planet's incredible story. We can understand how and why everything we see around us is here today. From the skies above us, to water, the essential ingredient for life. The ground beneath our feet. And finally, life. The spectacular result of a chain of catastrophes and coincidences. Each triumph, each disaster is a step on the trail that leads to here. To each and every one of us, right now. But Earth's story doesn't end here. A lot has happened, but there's more to come. The Earth will live for at least another 4.5 billion years. Everything we've seen on our journey is only half the story. Just imagine what wonders, what terrors, what strange creatures lie ahead for our restless, creative planet. The next chapter of Earth's story is still to be written.
Take another epic voyage in Journey Through the Milky Way, brand new next Sunday at 7. Stay tuned for 2012, The Final Prophecy.